Okay, so we'll try to solve one more problem on centrifugal pumps. So the outer diameter of the impeller of the centrifugal pump is 40 centimeter. So outer diameter is given. Outer diameter D2 is equal to 40 centimeters in sense. In the meters it is 0.4 meters. And the width of the impeller at the outlet is 5 centimeter. So width, that means outer width is specifying. Outer width, that is nothing but beta 2, which is equal to 0.05 meters. So 5 centimeters in meters I am converting. The pump is running at 800 rpm. So speed is given. Speed is 800 rpm. Working against the total head of 1.5. Sorry, 15 say 1.5 meters in the sense. Okay, so this is a printing mistake here. It is 15 meters. This is so manometric head, which is given as 15 meters. The vane at outlet is 40 degrees. So vane at outlet. So outlet vane angle, outlet blade angle is how much? 40 degrees. So I'll immediately write it here. So this is given as 40 degrees. Next. And the manometric efficiency is 75%. So manometric efficiency is how much? 75%. Find. So what we need to find in this problem? To find. Okay. Velocity of flow at the outlet. So what is velocity of flow at the outlet? Velocity of flow is what? Velocity of the flow is Vm. At the outlet is 2. So Vm2 is being questioned. Next. Angle made by the, second one is velocity of water leaving the vane. Velocity of the water leaving the vane is nothing but the absolute velocity at the outlet, which is V2, that is being questioned. Next, the angle made by the absolute velocity at the outlet with the direction of motion. So angle made by the absolute velocity at the outlet. Where is absolute velocity? So here is the absolute velocity. Angle made by the absolute velocity is what? Alpha 2. That is being asked as alpha 2 is being questioned there. Next, discharge. Of course, Q is being questioned. So all these things you have to calculate. So let us start the solution. So since he has not specified anything, what you can tick? Assuming backward vane. So when you have assumed backward vane, you will get this particular velocity triangle. Now immediately apply tan beta 2 there. Tan beta 2 is equal to Vm2 divided by U2 minus of Vu2. So I guess you can calculate the value of U2. It is pi d2n divided by 60. That is equal to pi 0.4 into 800 divided by 60. So you'll get U2 around 16.75 meters per second. I will immediately write here also 16.75. Next, what you can do is you can use the manometric efficiency to calculate U2. So manometric efficiency is given by manometric head divided by Euler's head. Correct? So that is in turn equal to, what is Euler's head? Euler's head is U2 Vu2 divided by G. So this is the Euler's head. Okay. So from this, what is Vu2? So Vu2 is given by G into manometric head divided by U2 into manometric efficiency. So substituting all the things you'll get. So 9.81 into manometric head is 15 divided by U2 value we have just calculated as 16.75. Efficiency is 0.75. So from this you will get the value of Vu2, 11.71 meters per second. So this is the value of Vu2 there, and this is the value of U2. And why are you calculating all this stuff? To calculate the angle of beta 2. Okay. Next, beta 2 is being given, so we'll calculate the Vm2 from this now. Taking that particular expression again, tan of beta 2 is equal to Vm2 divided by u2 minus of Vu2. What you will get? So tan beta 2, in the sense he has given beta 2 as 40 degrees, that is equal to Vm2 you are supposed to calculate now. U2 and Vu2 you have just calculated. U2 is 16.75 minus 11.71. From this, the value of Vm1, which is the first subbed, Vm2 is 4.23 meters per second. Okay, I'll immediately enter here as well. This is 4. Next, you have to calculate the value of alpha 2, which is this. You have to calculate the value of V2, which is this. Okay, you have the value of this and you have the value of this, and Vu2 is also calculated. I'll just enter the value. It is 11.71. So you have the value of this and this, so you can apply Pythagoras to calculate the value of the hypotenuse. So V2 is equal to, V2 square is equal to Vm2 square plus Vu2 square. So that is equal to square root of 4.23 square plus 11.71 square. So this is 12.45 meters per second is the value of V2. Okay. So once you have calculated that, you can calculate alpha 2 also. So tan of alpha 2, if you apply, it would be Vm2 divided by Vu2. So that is equal to alpha 2 equal to tan inverse of Vm2 is how much? 4.23 divided by 11.71. So alpha 2 value would be 19.8. The last one, the fourth one, if you want to calculate, that is the discharge, that is given by A2 into Vu2, A cross V, A2 into Vu2, Vm2, flow velocity, no? So flow velocity we have to take. So this is pi d2, B2 is the area cross Vm2. So that is equal to pi, d2 value was 0.4, B2 value was 0.05, and Vm2 value was 4.23. So if you all calculated, Q will turn round to 0.265 meter cube per second. So this is the value of fourth subject.